All right, now hopefully, hopefully we can see this. All right, so we're going to do chapter 9. Oh, I can't see that. Oh, I'm blocking the thing, aren't I? Chapter 9. Oh my goodness, chapter 9. Okay, it's barely on screen. Okay, keep me honest on that. It's hard for me to see, be my cameraman and my thing here. Chapter 9. Even though it's backwards there, when you see it on the video, it'll be okay. All right, so we're going to talk about scatterplots and correlation. Okay, so these are two preliminary steps when trying to find out if two variables are related. Okay? So we'll talk first about scatterplots. You could think of this as the first step of analysis. Okay? And it is a visual representation to show, we're okay here, the relationship between two variables. Okay? All right, now, I realized I went off the board there. Okay, so I don't have a lot of room here because I'm so close. All right, let me ask you guys a question. Do you think that your shoe size and your height might be related in some way? I'm getting some yeses and some nos, okay? Let me ask you it a different way. Do you think that tall people have bigger feet than small people? Yeah, that probably makes sense, right? We'll do some data collection here and we'll see if that might be the case. Do you think that your height would be related to your test score? No, you would probably think that that would not be related, right? Okay, so we've got different types of plots that I'd like to look at. And so when we talk about this, one of the things we're talking about, you might have different kinds of plots like this. Now I'm off camera already. There we go, I can do that. Okay, maybe I'll get a darker marker. I don't know why this is so light, okay? So if I were to have shoe size and my height, I might expect there to be some sort of a pattern like this, okay? If I were talking about my height, I'm off screen again. There we go. If I were to talk about my height and my test score, I might expect that there would be no relationship, okay? With this shoe size, you can kind of see there's a straight line relationship, okay? You might, with this, you might see no relationship. This would indicate, this is what we would refer to as a null plot, indicates no relationship. Okay, now this type of, I could also say, this, we could say that this is a positive linear relationship. Okay, or maybe, yeah, we're still on screen here. Maybe if I were to take the time that I spend exercising and my weight, would you think that people who, as a general rule, people who exercise more would weigh less? Would you think that would be an appropriate thing? Okay, so we might expect maybe some sort of a negative relationship, okay? People who exercise more, they weigh less, so this would be a negative relationship, meaning as people, so as this one, tall people have bigger feet. People who exercise more have lower weight, okay? So this would be an example of a positive linear relationship. This would be an example of a negative linear relationship, okay? Now there are lots of different relationships that you could have, okay? You could have something that looks like this, okay? Does that look like a straight line to you? No, okay? Now, other than the fact that I want you to recognize that this is non-linear, or, turn this a little bit again, or if it was something that looked like this maybe, do you see that that's not a straight line either? Okay, so this would also be an example of a non-linear relationship. So the first thing that you should do is when you're trying to figure out if two variables are related, you want to create a scatter plot. Now typically on your x-axis, this is going to be your independent variable, this is going to be your dependent variable. Now sometimes that's a little bit hard to figure out, okay? Does your shoe size affect how tall you are? Or does how tall you are affect your shoe size? You could probably argue that either way, right? And the fact of the matter is, even if I were to flip these, I may expect a different slope, but it's still going to be positive. And if I had my height here and my shoe size here, okay? Sometimes it's a little bit hard to figure out which one's your independent variable, which one's your dependent. But in the case of time spent exercising as weight, does the time you spend, or let me put it this way, does your weight depend on how much time you exercise, or does the time you exercise depend on your weight? The first one, right? You would expect that as people exercise more, your weight would be dependent upon that. So you're going to put your dependent variable here, you're going to put your independent variable on the x-axis. Does that make sense? Now, it's not a hard and fast rule, because in the case of shoe size and height, which one depends on which? You could argue it either way, but if it makes more sense, like the time spent exercising and the weight, you should put the time on the x-axis if possible, and the weight on the y-axis. Does that make sense? Okay. All right. So I've got some examples. One of the things I'd like to do here is I've got some here we go. No, I want to do this. I'm going to go to Wikipedia. I know some people don't like Wikipedia. I like it. I think it's pretty good. Okay, so let me share this with you. Share. Okay, so this comes from Wikipedia. Now the thing that I want to talk about, so these are some scatter plots. They don't have a scale on here, but the one thing that I want to point out here is you can see here, these are all perfectly correlated. Oh, I should also mention, okay, I'll write that on the board even though I'm sharing this. But correlation, the correlation coefficient is represented by the letter R. I don't really know why. And it's always between -1 and +1. Okay? Now, here's some examples here in Wikipedia. So these are all perfectly correlated. If you were to correlate your height with your height, it would be perfectly correlated. Okay? Now, all of these are equally correlated. You'll notice that the slope, like this one, is steeper than these. These are flatter, okay? We would say they were all equally correlated, okay? These are all in the negative direction. So when I talk about negative, I'm talking about the kind of the slope, but I'm not necessarily talking about the slant, okay? We would say that these were all equally strongly correlated. Now, the idea with a scatter plot is it measures how much variation you have. So you can see here, this is strongly correlated. Now we've got a correlation of 0.8. It's still pretty strong. Sometimes we would refer to that as maybe a hot dog shape. This one, you can see here that it's basically, it's still positively correlated. It's kind of in that area here. This one sometimes you'd refer to as a hamburger. This would be an example of a null plot. Okay, if you have a null plot, then that would indicate that you have no correlation. Okay, so test scores and your height, for example, you would expect those would not be correlated. These are all, so +4, -4, these would be equally strongly correlated or weakly correlated, as the case may be. The stronger you get to the ends, this is strong correlation, this is strong correlation, and then these are weaker correlations in here, okay? Now the equation for the correlation coefficient is, sorry, oh, now it's pointing down even worse. There we go, okay? The equation is R equals the sum of x sub I minus x bar over s sub x times yi minus y bar over s sub y. All of this divided by n minus 1. So that's the equation. Now you don't necessarily have to memorize that equation. I will give it to you, but I do expect that you will be able to take this equation just as you did with the standard deviation and be able to calculate this, okay? So let's do, now the other thing that I just want to mention this assumes linear correlation, okay? Now that's a big assumption. Let me go back to Wikipedia for just a minute. As we look at this bottom row, one of the things that you'll see with these scatter plots is these all have a 0. All of these have a correlation coefficient of 0. So what I want to caution you on, if your scatter plot looks like this top one in here in the middle, and it has a 0 correlation, this would indicate that there's no correlation. However, if you don't look at your scatter plot and you just plug it in that equation, these all have 0 linear correlation, but that does not mean they are not correlated, okay? In this case here, we can see that we've got a big wavy pattern here, okay? So it's important to combine the scatter plot with the correlation coefficient. If you only look at the correlation coefficient, you may wrongly assume that there's no correlation going on, when in fact there is, okay? All of these are correlated. These look fake to me, but this is something you could see in real life, okay? So always do your scatter plot first. If it looks like, you know, one of these, then you can plug it into the equation. If it looks like one of these, you probably shouldn't figure out your correlation coefficient. So this is something you would see. This is something you would see here. This looks like 2 different populations. That's kind of weird looking. This looks like a petri dish or something, I don't know. But to me, this looks like you got 4 populations going on. So correlation and scatter plots are related in the fact that you should always do the scatter plot first. Make sure it looks something like the top row. If it looks like the bottom row, well, you don't need to calculate the correlation coefficient. Okay, some people often skip the scatter plot and they just assume, oh, it's going to be a straight line when it may or may not. So that can be a dangerous thing to do. Now, here's what I would like to do. I would like to go ahead and collect some data here. And we're going to collect shoe size and height. And we're going to see how strongly they're correlated. Now, by the way, let me do one more thing before let me stop sharing this. One more thing here. Okay. Okay, I'm going to give you a rule today, and then probably on Thursday I'm going to break it. But This rule will stand for today. Okay, so if I take the absolute value of R, if the absolute value of R is greater than 0.7, I'm going to call that strong. Strong correlation, okay? If your R, the absolute value of R is between 0.3 to 0.7, I'm going to call that moderate. And if your R is less than 0.3, I'm going to call that weak. Okay? Close to 0 implies no correlation if, and I'm going to box the if, the scatter plot is a null plot. Okay, and that's a big if. So make sure before you assume that something has no correlation that it is a null plot. Okay? All right, so now let's collect some data in here. I'm just going to go around the room. Share. Okay, so Emily, can you tell me your shoe size? You're 9, and your height is 5'7", so that's 67 inches. Okay. Is it Sarah or Ashley? Sarah. 7. So you're 64 inches tall. Now notice these, another thing that I forgot to mention, correlation is unitless, okay, which means it doesn't depend on units. Notice we're comparing inches and we're comparing shoe size. Those are two completely different measurements. Is it Sarah or Ash? Gabby. And you're 5 feet tall? So you're 60 inches tall, okay? (5'1", you're 61 inches tall, Penzi. 7, you're 64. 10 and what? 69 inches? 71. 9, 71. 61. 64. 68. 5'3", 63. 66. 54 inches. 64 inches. Boy, you'd be really short then. 71. 70 inches. 5'9", so you're 69. 69. Okay. 9 and 69. 68. 67. And 61. Okay. I'm going to make this a little bit smaller so that we can see them all on the same page. Okay, so what I want to do is I want to focus back on my equation here. What do you think X bar represents? Maybe I'll put some steps. I know you guys like to follow steps, right? Step number 1, what do you think X bar and Y bar represent? It represents, so we need to find the sample means. Okay, yes. S sub X and S sub Y, yes. Okay, so X bar and Y bar, those represent your sample means. So I need to find the mean. Now, by the way, let me just emphasize here, just to make your lives easier, always put a gap between any of your summary statistics and your data. So I'm going to find the means. So basically, I'm assuming that my shoe size is X and my height is Y. Okay? Now, how do I find my mean quickly and easily with Excel? Equals what? Equals average, right? Okay, so the mean shoe size in this class is 8.34. The mean height in this class is 66.28 inches, okay? Now, what do you think S sub Y and S sub X represent? What does S usually represent? Sample. What did we have on our quiz today? Standard deviation. Okay, so step number 2 is find the sample standard deviation. Okay? Now, your standard deviation, what's the command for standard deviation? Did I show you the cheater method for standard deviation last time? Equals STDEV, right? I've got 2 equals there. Now, you can use the .s or you can use this one with nothing on it. Standard deviation, that's also a sample, okay? So the sample standard deviation is 1.66 and 3.52, okay? Now, basically, each one of these, I should have probably done the normal distribution first, but each one of these represents data minus the mean over the standard deviation, okay? I'm going to give you a preview of one of our future, I almost called them episodes, future classes. That's what we often refer to as the z-score, okay? So I'm going to take here, in this case, I need to find the z-score for the shoe size, okay? So it's important that you use your parentheses here. It's going to be the data. I'm going to subtract off the mean. Because I want that mean not to change when I copy my formula, I'm going to press F4. And then I'm going to divide by my standard deviation. Okay, I want that not to change. I'm also going to press F4. Okay, now I'm going to copy this down. You'll notice in here the A26 and the A27 don't ever change. If you're looking up here in the formula bar, notice those 2 don't change, but this first number does change, okay? Now go back and watch this video again if you think I'm going too fast. Yeah, this is called the z-score, okay? Then we're going to do the z-score for the height, okay? So I'm going to pick on Hannah. Can you help me find the z-score for the height? We're going to take our data, so 67. We're going to subtract the mean, which is 66. I'm going to press F4, and then I'm going to divide by, which is 3.52. I'm going to F4 that as well, okay? Now I'm going to copy that down. If you double click right here on the corner, it will copy it down for you, okay? Now, what's my formula telling me to do? I'm going to find the product of my z-scores, okay? So product. Now, let me just warn you guys, this is going to be on your next test, all of these steps. So if you haven't memorized them, oh, actually, I'm skipping a step. Okay, so step 3 was find the z-scores for X and Y. Number 4 is find the products of the z's, okay? Your product is going to be this times that, okay? Now I'm going to copy that down. What does this funny looking E tell me? Find the auto sum. Okay, so I'm going to find the sum. Okay, step number 5 is find the sum of the products. Okay, I'm going to add that column up. Okay, and then step number 6 says what? What's the last step? What's that? Divide by n minus 1. Divide by n minus 1. Now, by the way, let me ask you a question here. Remember, Excel will count for you. Do I divide by 23 or 46? What do you guys think? Okay, what do these represent? Each one of these represents the same person measured twice, right? So this is going to be n minus 1 pairs. Okay, so in this case, I'm going to divide by what? 22, n minus 1. Okay? And so I'm going to take this and I'm going to divide by 22, which works out to be 0.78. Okay, now according to our board here, would this be strong, moderate, or weak, or no correlation? Strong correlation, except for what did I do that I told you guys I should not skip? And I already skipped it. I was so focused on the calculations I forgot Scatterplot. That's what I heard you now. Okay, yes. So I got a value of 0.78, right? That's greater than 0.7, so we're going to call that strong. Now, but I've made a big mistake because what if my scatterplot is nonlinear? I didn't check my scatterplot, did I? Okay, so let's pick on John on the back row. If you were to create a scatterplot, how do you think you would do it? Highlight your data. Insert. Don't do that. That'll just confuse you. Yeah, but I'm saying I don't want you to do that. Excuse Scatterplot. Yeah, that's the better way to go. Okay. So what do you think? Now we haven't labeled this properly, have we? Okay. What do you think? Does this look like a straight line to you? Usually it does, but this one doesn't really. This one kind of has a bow in it, right? So is linear correlation a good idea in this case? Probably not. Okay, I went and did all the calculations and then looked at my scatter plot. I should have done that sooner. Do you see that this kind of curves down like this? It's kind of a banana shape, isn't it? I should have done that before I went through all those calculations. I already made a mistake in front of you guys, okay? So remember, this is actually the first step. You should always do this first. Now, this is very unusual. You are the most unusual class I have. I've never had a class that didn't look linear. But why do you think it might not be linear in this case?
Well, women's shoe sizes and men's shoe sizes are different.
Ah, men and women are different, right? Different shoe sizes. So that probably messed it up. Maybe we should have done that. Maybe separate the women from the men. That could be a reason why this is more curvy than normal. Okay. We've mixed some populations. Okay. All right. I'm going to pretend because the steps are good. Now, a good graph is properly labeled, right? How do I properly label this? Hit the green plus sign. Axis titles. What goes down here? Shoe size. What goes over here? Height measured in what? Inches. Make sure you put the units on there, okay? And then what could I change the title to? Math 1040 men and women. Okay. All right. Now, if I'd have done the scatter plot first, I might not have gone through all those calculations because, as I said, that looks kind of curvy. So I probably shouldn't have done that. But yes, go ahead. Yeah, that's as a general rule. That's we're going to go with that. Okay. Yes. No, not 5. That's an S. Yeah, S. This is S. So just a reminder. Shall I make this look more like an S? Here, I'll stop sharing here. Okay. This is not a 5. It's the letter S. And that is also the letter S. Okay. So there's no 5s in it. Okay. Now, another thing that I want to talk about. Let me share this. You've probably heard the phrase, correlation does not imply causality, right? Spurious correlations. This is a cool website, Tyler Vegan. Okay. Now, these are some examples of nonlinear correlations, but what I love about this is these seem to show really strong correlations. Do you think that US spending on science, space, and technology is related to suicides by hanging, strangulation, and suffocation? The more you study science, the more you want to kill yourself. Is that how it works? Okay. Do you think, it looks like those are correlated, right? How about this one? The number of people who drowned by falling into a pool and films that Nicolas Cage appeared in, right? Doesn't that make you want to fall in a pool and drown? Right? Isn't Nicolas Cage films obviously cause you want to drown, right? How about this one? Per capita cheese consumption and the number of people who died by becoming tangled in their bed sheets. Stay away from cheese. Okay? Now, this has got some fun ones here. We'll talk about the divorce rate in Maine and the per capita consumption of margarine. If you eat margarine, you're going to have a bigger divorce, right? Do you think those are related? Okay, so the old adage, correlation does not imply causality. Correlation is not the same as causation. Yes, certainly. So we have to be a little bit careful about this. There are some things. So correlation is kind of a weak form of analysis. Okay. There could be other things. Gosh, you know what I would really like to do? I don't think I have time though. Maybe I'll save that for next class. But there is, I won't give it away. I'll save it for next class because it'll lead into what we're talking about on Thursday anyway. So on Thursday, we're going to talk about so if you see something that looks like it's pretty good correlation, you could see that shoe size and height, those seem like those should be related, right? So does shoe size cause you to be tall, or does being tall cause you to have big feet? It's kind of hard to make that justification. But just remember that a lot of times correlation can be used to predict things. We'll talk more about that in the next chapter when we're going to talk about regression, okay? So do you guys have any questions for me? Yes. If scatterplot is a null plot. Null, N-U-L-L, null. Okay. All right, so quiz Thursday will be in here. And in this room again on Thursday. Okay. So if you want to do your test corrections, get those done within a week. I'm not going to put a due date on that. You're just going to have to know that it's due within a week. So after that, I'm not going to check it anymore. All right, see you all on Thursday.